Alright, welcome to projectile motion now. We're going to take our vectors and work in projectile motion. Projectile is an object which the only force acting on it is gravity. So this is kind of important, that the only force, we've already talked about forces, and the only force working on it is gravity, so gravity is pulling down. We have some examples here. If somebody drops a ball off of a cliff, it's going to go straight down. As you see, the balls are getting further and further apart, showing that it's speeding up due to gravity. If you throw a ball up and down, if you look at every single one of these heights, as it goes up and comes down, it's going to be at identical spots. So now we're talking about projectile motion here. As it goes up and down, it goes up and down, but if you look, the ball is at the same height as it goes across here, which is what makes this very easy to work with. Realize that the only force acting upon an upwardly moving projectile is gravity. Anytime you throw something in the air, the only thing, because we're neglecting air resistance, no air resistance at all, the only thing that's going to affect it is gravity, and that's going to be pulling down at 9.8. Don't be fooled by the common misconception that a force is required to keep an object in motion. A force is not required to keep an object in motion. A force is only required to maintain an acceleration. This is a key thing here. It will stay in motion, but to keep it accelerated is when you need a force, because remember, forces cause acceleration from our last test. A force causes acceleration. So a force is not required to keep it in motion. A force is only required to maintain acceleration. So, if I had a cannon and I fired it off, it would go in a straight line. This is a gravity-free path. It will keep going that way. Without gravity, an object in motion will continue in a motion with the same speed and in the same direction. Remember Newton's first law? An object in motion at constant speed will continue on in the same path, yada, yada, yada. Well, this is what it is. We have nothing impeding this, and there's no gravity to pull it down. Or you could say without gravity, you could launch a banana straight at a monkey in a tree. Notice the monkey does not fall when he catches the banana because there is no gravity. Okay, normally this has a little thing that goes with it, and the monkey drops down and the banana goes across, and you can hit the monkey because you have to time it, because this monkey and this banana need to hit at the same point. But with gravity, yeah, this doesn't work real well because the animation is not working on this recording. But he would fall down and you're trying to get him to catch it. And I'll talk more about this in class. But here's the gist of what they were trying to talk about in the last little couple slides. In the presence of gravity, the monkey also accelerates downward once he lets go of the limb. Both banana and monkey experience the same acceleration since gravity causes all objects to accelerate at the same rate regardless of their mass. Gravity is the downward force upon a projectile which influences its vertical motion and causes the parabolic trajectory, which is characteristics of all projectiles. Parabolic means this. It goes up, it comes down. It goes up, it comes down. It follows the curve. That's parabolic. Alright, I'm going to probably have to skip through these because this is basically just a little dot here because it had animations that aren't working. Alright, back to our cannon. Now we have this parabolic trajectory that as it goes down. With gravity, a projectile will fall below its inertial path. Gravity acts downward to cause a downward acceleration. There are not horizontal forces needed to maintain the cannonball's motion. But if you look at these lines, they are the same distance away as it goes down. And you get this parabolic motion as it's going. Alright, now we're going to go through characteristics of projectiles. Number one, projectiles always maintain a constant horizontal velocity. So remember our cannon, as that was curving down, the velocity on the x-axis will be the same. Say it's 10 meters per second. It will always be 10 meters per second all the way down. Because does gravity affect the x-axis? No, gravity only affects the y-axis. So whatever x velocity the cannonball had, it will maintain the whole time. Projectiles always experience a constant vertical acceleration of 9.8 meters per second squared downward when we neglect air resistance. So there's always going to be gravity affecting it. That's basically the definition of projectiles. Horizontal and vertical motion are completely independent of each other. I'm going to repeat that because this is the #1 thing to remember. Horizontal and vertical motion are completely independent of each other. What happens on the y-axis has no bearing of what happens on the x-axis, and what happens on the x-axis has no bearing on what happens on the y-axis. Therefore, the velocity of a projectile can be separated into horizontal and vertical components. So you split it up into 2 components to work. For a projectile beginning and ending at the same height, the time it takes to raise to its highest point equals the time it takes to fall back to its original position. So if I throw something up in the air and it comes back down, the time it takes to go up will equal the time it takes to come down. Objects dropping from a moving vehicle have the same velocity as the moving vehicle. So if you're driving in your car and you stick your hand out the window and let go of something, on the x-axis it has the same speed as the car, so it will keep traveling alongside your car if we're neglecting air resistance. But then it will start accelerating downward. Gravity accelerates objects downward but is unable to affect the horizontal motion. Gravity, you see how these are all equally spaced apart? Same spacing? Because nothing is accelerating that ball. That ball is staying the same speed. It's got a constant velocity. Where one that's dropping, it gets further and further apart because it's accelerating due to gravity going faster and faster and faster. So these gaps are getting further and further and further. So looking at this, our gravity-free path of the x-axis and our just vertical dropping of the y-axis help us determine the curved projectile motion path that it would take. So let's say we launched this at an angle and we had our gravity-free path where it would go in a straight line, but that doesn't happen, so it basically will curve down, doing the parabolic trajectory under gravity's influence. The distance any projectile goes is d, the distance it travels, equals 5 times the time squared. That should be, consider this t squared. So d equals 5 times the time squared. So only the time is squared there. You can figure out how far something goes on the x-axis. Alright, so when we are measuring the distance, we are measuring the downwardness and sidewaysness of the projectile. So if you looked at our cliff, something going off of it like this, we're measuring the downwardness and the sidewaysness, if those are actually words. Okay, now I'm going to talk a little bit about satellites. These are projectiles moving fast enough to fall around the Earth rather than onto it. We have all kinds of satellites going around the Earth. And what they have is if you have the Earth here, and you have your little satellite, I'll just put a dot up here, and it's traveling around the Earth, like so, what it is it's got a velocity that's going fast enough this way that Earth's gravity that's pulling this way isn't able to pull it in. It just pulls it to where it goes in a circle. The same thing is happening with the Earth around the Sun. The Earth is traveling fast enough, say that this is the Earth and not a satellite now, and this is the Sun. The Earth is going fast enough in this direction to basically be pulled in a circle around the Sun. So that's what our planets are doing. This is called tangential velocity. So here's some things about launch speeds and how to get off the Earth. Launch speed less than 8,000 meters per second, the projectile will fall back to Earth. So whenever they launch the shuttle, it has to go at least 8,000 meters per second, or it will get pulled back down into Earth's by Earth's gravity. Didn't I just say this, that launch speeds less than 8,000 will fall back in? Okay, launch speeds equal to 8,000 will orbit the Earth. So if this guy was able to go at 8,000, he's going to just orbit around the Earth and around the Earth and around the Earth. Now, if you have launch speeds greater than 8,000, you can projectile, it will get an elliptical path. So instead of just going around and around, you're going to get one that goes something like this. And it looks more egg-shaped as it goes around.